Hi, I'm Holly. I'm from Teach All About It, and today we're going to be doing some daily practice for revision. Today we're going to be looking at an exam question and an example student answer for the iGCSE Computer Science syllabus from Cambridge. So today's question, we are looking at hexadecimal, and you can see here we have a question that says hexadecimal and denary are number systems that can be used by programmers. Now the very fact that we have a question here that says that it's being used by programmers actually doesn't really give us any extra information, because all we're being asked to do is to convert these 4 hexadecimal values into their denary values. Now this question does have some working space, so you do need to show your working if you possibly can, and I'm going to get you to pause the video so that you can try first. Now this particular student has done a really good job here. They have successfully transferred everything, they've converted, they've put their answers at the top, but also their working space is really helping me as an examiner because I can see the method that they've used. Now working space allows us to give marks if we can see them. Now remember that we mark positively, so when we're marking, we're looking to give you marks, not take them away. So here I'm looking for a student who has converted each digit into a binary nibble, and you can see that by using these little things down here. Now I can see this student has put in each of them and converted them into nibbles and has almost like little arrows that show me each of the different nibbles. The next thing is then to combine them as a full byte, and again I can see this happening over here because I can see the full bytes over 1, 2, 4, 8 all the way up to 128. And again converting that into then denary, and then you can see then adding up the ones. So let's have a look and see how we might do that in our own version, and I will show you mine. So I've divided up the page a little bit differently so that I can show you the working. So 0, 9, what I might do is underneath put 0 and 9. So 1, 2, 4, 8. So at this point I might then go, so 0, well that's nice and easy because I've got 0, 0, 0, 0, and then 9. I'm going to go 1, 2, 4, 8, 8 and 1, that's my 9, and there. Now if I wanted to keep this into just a single area, what I can then do is just to convert the second nibble. So I can go 1, 2, 4, 8, and then over here cross it through and do 16, cross it through 32, cross it through 64, cross it through 1, 2, 8. Now notice there that I could have just put in 16, 32, 64 because actually the digit's already there. But the reason I'm crossing it through is to use this idea of signposting. And signposting, what it does is it's screaming, I would like some marks. And those marks are over here. Look at how I'm doing this, you're showing the process. So at this point what we're going to then do is we're simply going to add up the ones using our entire bit. So here 1, 2, 8, no, nothing over there. We do have one on the 8. Oops, I've just used a black highlighter, that's not going to help me at all. There we go, let's highlight that in yellow. I've used an 8, I've used a 1, and so 8 plus 1, that's a 9. There we go. So let's do exactly the same over here for our 1, 0. Now 1, 0 is slightly different. So we're going to go 1, 2, 4, 8, and again 1, 2, 4, 8. And we're going to do that. So you could either split them up visually or you can use those little lines that our student used. So 1, 0, 0, 0 and 1, and then nothing on this side. We're then going to cross it through, make sure that we're signposting 32, 64, 1, 2, 8. There we go. So we're signposting. This one is 16. We're going to highlight that so you can see that's the one we're using. You don't need to highlight in your exam, but you can do if you want to make it really clear. Remember, when this is scanned, they're not really going to pick up on the highlighting. It will just look a little bit grey. So in this case, we have 16. 28 will be exactly the same. So we're going to do a 2 and an 8. 1. Let's make that a little closer. 2, 4, 8. 1, 2, 4, 8. That's going to be a 1 over there for an 8. 2 is going to be here. So you can see they're not making particularly difficult numbers. We just have to then show the process. It's all about the process rather than the maths. 64, 1, 2, 4, 1, 2, 8. So you're doing the same thing over and over again. So it's a nice sort of simple 4 marks because you're showing the process, but each one of these has a slightly different way of explaining. So you've got a nibble with 0 at the beginning for the 0, 9. You've got a nibble with the zeros at the end for the 16 to show that you're combining. The 28 is showing what happens to two numbers. So here, if we're looking at two numbers, you can see here we've got 32 plus 8. So this is showing that you are actually adding up the numbers together. So 32 plus 8, we've got 40. And then A1 is slightly different, and this is showing your understanding of the digits. So A1. The other thing with signposting, again, I'm going to go A equals 10, just to show I really understand what's going on here. 1, 2, 4, 8. 1, 2, 4, 8. So this is basically, this last one is showing your understanding of the digits and everything else that you've done so far. So we have a 1. I do apologise if you can hear those seagulls. A is 10, so 8 plus 2. There we go. 16, 32, 64, and 128. So same thing, we're going to take our highlighter. We need to do 128 plus 32 plus 1. Now, of course, if you are a little unsure of your maths, remember you can always do a little bit of scribbling at the side. If we have 128 and we've got 32, try and do something like 28, 32. We've got a 1 over here. We can always then put a 1 down here. Try and do it longhand. It's absolutely fine for you to do this. 8 and 2 is 10, 11. Let's carry that. 2 and 3 is 5, then 6. And then the 1, we've then got 161. So if you do need to do that as a longhand addition, that's absolutely fine. There's no reason for you not to put your extra working out on there. So would you like your question featured on here? If you've been studying and you have a past paper question that you'd like me to answer and give some examiner style feedback, you can go to www.teachallaboutit.school and you can submit your GCSE, iGCSE or A-level computer science questions for free.